hope you're doing good. இந்த வீடியோவில் நம்ம இதை பற்றி பேச போகிறோம்னா we're going to talk about an important vulnerability which is inflation vulnerability. So we have a contract called wallet. So அந்த வாலெட்டில் இருக்க what is the vulnerability and how to solve it, and we're going to write the foundry test script to prove that the vulnerability exists in that code, right? So I will go through the contract and I will explain you the vulnerability and how to test the vulnerability, and in the end of this video we will discuss the solution for it, right? How to solve this. So without further delay, let's get into the video. Hope you will gain some knowledge at the end of this video. So yeah, so I have loaded the contract into the remix. I'm using Brave browser, so I think it's okay, right? So we have interface and we are importing the test and console 2 from Foundry. Maybe in next video I will try to implement this in Foundry, but this video I will just want to explain you the vulnerability, right? Rather than implementing it, I will explain it. And if you want to see the implementation, I will just create a new Foundry project and I will implement and show you the results of it. And thanks to Solidity by example, I got this example from that website. Hope you gain some knowledge in the end of this video. Yeah, let's get into the video. So we have interface for IRC20 and a simple token contract which we inherit from this interface, and we are implementing the transfer, approve and transfer from. So this is nothing but the balance which has been recorded using the mapping data structures in Solidity, right? That's more than it. Here you can see we are adding the amount to the balance of and the total supply. It's very easy. I will link the code below, you just go through it, but it's a simple token, ERC20 standards, right? And we have a wallet. Inside the wallet we have a constructor which takes the token address, and we are calculating, we are making the note of total supply and the balance of, right? So this two mint and the burn functions are private. Here you can see whenever we call the mint function with the 2 and the share, we are going to increment the total supply by the share, and also we are going to increment the balance of for this address by share amount. And the same goes with burn. Instead of adding, we are going to decrement it, and we'll come back to this. Here they have explained about the steps to implement the hack on this contract, right? So we have the deposit function. This is very important function. This deposit and withdraw functions are very, very important. Like when depositing, if the total supply is 0, and the share is going to be the amount of the amount that you deposit is going to be the share if the total supply is going to be 0, right? If the share is the total supply is not 0, then we're going to calculate the amount of the share with this formula: amount multiplied by the total supply divided by the token balance of this contract. And we're going to mint the amount of share to the message.sender who have called this deposit function, and we're going to transfer from the message.sender to this address of this the amount that the user is interested in deposit into the contract, right? And we have a withdraw function which takes the shares, and here you can see we are multiplying by the total supply. Here we dividing by the total supply in order to calculate the amount, and we are going to burn the amount, and we are going to transfer it to the message.sender and return the amount. So that's it. So how to implement and hack, or how to hack this contract using the inflation vulnerability? So the thing is, like, we have, let's consider there are two users, right? Address 11 and address 12, right? So the user 1 is going to deposit 1 Ethereum into this contract, and the user 0, instead of calling the deposit function, this time he's going to donate it by calling the transfer functions. So in this case, the deposit function is not called, but the balance of the contract has been increased by 100. because he is depositing 100 Ethereum to the contract. And when the user 1, again after the user 0 deposits 100, the user 1 also deposits 100. So the balance is going to be 201 Ethereum to the on the contract, but the share is going to be 1. Why? Because I will show you. It's because this formula. Here you can see the numerator is smaller when compared to the denominator. So in this case, the solidity rounds off this into 0, so that when the user 1 deposits 100, the amount of the share minted to the user 1 is going to be 0, right? So the user 1 is not going to get any share. Okay, so only the user 0 has 1 share. So when he withdraws the amount, he is going to get 200 Ethereum instead of 100 Ethereum which he deposited. It's because, like, instead of calling the deposit function, he cleverly transferred the amount into this contract, which made this vulnerability. So what is the solution for this? It's simply, instead of calculating the share with the help of token.balance_of, use an internal variable in order to calculate. For example, whenever I deposit some amount, whenever a user deposits some amount to this contract, keep an internal storage in order to save the amount of the Ethereum a user deposited. Okay, have an internal accounting whenever someone deposits the Ethereum to the contract. That's one way of solving this vulnerability. So there are other ways, but this is going to be the important in order to avoid this vulnerability. Or else you can also check for the minimum mintable share, right? So if this amount of share is not minted, then we are going to revert the function, right? So that's another way of handling this vulnerability. Hope you got some content. Feel free to comment in this video if you have any doubt regarding this vulnerability, and I am ready to help you out in order to understand blockchain, Web3, vulnerabilities, smart contracts. So connect with me on LinkedIn and subscribe for much more relevant videos. So thank you for watching. See you on the next video. Until then, this is Balamurugan Nagarajan signing off. Peace.